What if I told you that scientists are figuring out how to put humans into a deep sleep for months, maybe even years, and wake them up like nothing happened? This is not science fiction. This is happening right now in labs funded by NASA and the European Space Agency, and it could change everything we know about space travel. Here is the problem nobody talks about. A one-way trip to Mars takes roughly 7 months. A mission to Jupiter's moons could take 6 years. Astronauts would need tons of food, water, and oxygen. They would lose muscle mass. Their bones would deteriorate. Radiation would shred their DNA. And psychologically, imagine being trapped in a metal box smaller than your apartment for years. People would break. Now here is where it gets wild. Nature already solved this problem millions of years ago. Bears hibernate for up to 7 months every winter. Their metabolic rate drops by 75%. Their heart rate falls from 40 beats per minute to roughly 8. And here is the part that baffles scientists. Bears lose almost zero bone density during hibernation, even though they are completely inactive. Astronauts on the International Space Station lose 1 to 2% of their bone mass every single month. Bears somehow do not. Researchers at the European Space Agency have been studying exactly how bears pull this off, and they want to replicate it in humans. Now stop for a second. You might be thinking this sounds dangerous. You would be right to question it. But here is something most people do not realize. Doctors already put humans into a version of hibernation. It is called therapeutic hypothermia. When a patient suffers cardiac arrest, surgeons cool the body down to around 32 degrees Celsius. This slows metabolism, reduces the brain's need for oxygen, and buys critical time. People survive because of this procedure every single day in hospitals around the world. The science of slowing the human body down is not theoretical. It is medical reality. SpaceWorks Enterprises, funded by NASA, proposed something called torpor-inducing transfer habitats. The concept involves cooling astronauts' bodies through the nose using a method called rhino-chill, lowering core temperature just enough to trigger a torpor state lasting days or weeks at a time. Their calculations showed that a crew in torpor would need dramatically less food, less water, and a significantly smaller spacecraft. That means lighter missions, lower costs, and fewer resources wasted. But here is the controversial part. In 2020, researchers at the University of Tsukuba in Japan discovered specific neurons in mouse brains called Q neurons. When activated, these neurons triggered a hibernation-like state in mice, animals that do not naturally hibernate at all. Body temperature dropped, metabolism collapsed, and the mice woke up days later completely healthy. This was published in Nature, one of the most respected scientific journals on the planet. It suggests that the biological machinery for hibernation might already exist inside mammals, possibly even inside us. Now think about what this means. If scientists can safely induce torpor in humans, deep space missions become survivable. Radiation exposure drops because cells in torpor show higher resistance to radiation damage. Muscle and bone loss could be dramatically reduced. The psychological toll of isolation nearly disappears because you would simply sleep through the worst of it. We are not there yet. Human trials for space torpor have not begun. But the research is accelerating faster than most people realize. The first humans to reach Mars might do it with their eyes closed. If you found this fascinating, follow this page because we break down the future before it arrives. Now, here is my question for you. If hibernation pods became available for a Mars mission, would you volunteer to be put to sleep for 7 months in deep space? Tell me in the comments.